Okay, so we are still on integration by substitution, and this is the fourth video. So let's look at this problem here and let's see how we're going to solve this. So we have the same problem here written here, and just looking at the problem, we know we cannot integrate directly. This is not in standard form. So in this video, we're going to be applying a U substitution, but this is not the regular U substitution will not work here, because look at the denominator. The derivative of this denominator will not give a value that is the same as the numerator. So this is a bit tricky. So what we can do here, we can just manipulate the expression in such a way that the denominator, the derivative of the new denominator we're going to get will now give a value that is the same as the numerator. So we're going to rearrange this. We are going to divide, since by looking at the question now, my variable x raised to the power 2 is the highest here. I can't find any x raised to the power 3 anywhere. So I'm going to divide every term by x raised to the power 2. And then if I divide every term by x raised to the power 2, every single term by x raised to the power 2, I will get a new value as my denominator. And I'm going to see and check if that new denominator, if its derivative will give a value that is the same as the numerator. So, but first I will have to expand this. So expanding this one, let me write this one again. So you have the integral of x squared plus 1 over, then let me expand this. So I'm going to get a new value. So expanding that, I have x raised to the power 2 minus 1 times another x raised to the power 2 minus 1, since it's raised to the power 2. So expanding, this gives me x raised to the power 4 minus x raised to the power 2 minus x raised to the power 2, then plus 1. Then I have x raised to the power 4 minus 2x raised to the power 2 plus 1. So this is what you get if you expand this one. So I'm fixing this one here now. So we have it this way: x raised to the power 4 minus 2x raised to the power 2 plus 1. Then, of course, still with respect to x. So finally, I can now divide every single term with x raised to the power 2, and let's see what we're going to get. So dividing every single term, let me start with the numerator. So the integral, I still have x raised to the power 2 divided by x raised to the power 2 plus 1 over x raised to the power 2. Everything over, spread this. This one, the same thing too. X raised to the power 4 divided by x raised to the power 2 minus this 2x raised to the power 2 divided by x raised to the power 2, and then finally plus 1 divided by x raised to the power 2, still with respect to x. Then we're going to get, so this cancels out, we get 1. So I have the integral of 1 plus, this is still 1 over x raised to the power 2, everything over. So this one, okay, x raised to the power 4 divided by x raised to the power 2, by laws of indices, I still have x raised to the power 2 left, because you pick one x and then you subtract the power. 4 minus 2, you get 2. Then minus the x squared cancels x squared, I have minus 2. Then plus 1 over x squared. So you have it this way. Then looking at the denominator now here, we can still factorize this denominator. So factorizing this by completing the square, we just still have the 1 plus 1 over x squared. Then factorizing this denominator, I'll have x minus 1 over x all squared. So this is what we're going to have. So now looking at this, the derivative of the denominator now will give us the numerator. So this is now in standard form, of course, with respect to x here and with respect to x. So this is in standard form. We can now start our integration process. This is just our simplification process. So from this form that is not standard, we now have a standard form that we can now use our U-Substitution method to integrate. So going further from here, we can now rewrite this, and we will make this one our U. So U equals what is in the bracket? U x minus 1 over x. That's all. So we are only making the value in the brackets to be our u. Then of course we differentiate with respect to x. So we now have the u dx equals to, then derivative of x is just 1, then minus derivative of x, 1 over x. Let's quickly do that somewhere. So derivative of 1 over x, carefully, 1 over x can be written as x raised to power minus 1. So if you minus 1 times 1 gives me minus x, then minus 1 minus 2. So this is minus 1 over x squared. So that's it. So this is now bracket minus 1 over x squared. Then the u dx is now equal to minus times minus is plus. So that's 1 plus 1 over x squared. And of course, I can treat this du dx as a fraction because in the original standard question that we have, this is the standard one now, we can try and replace our dx. So I'll make dx the subject of the formula here, and anything I get for the value of dx, I'll replace it here. So I can now cross multiply, since I'm taking this as a fraction, put this everything over 1, and then I'll cross multiply. So dx times this will give me what? That'll be dx 1 plus 1 over x squared equals to du times 1 is what? Is du. Then if I divide through by 1 plus 1 over x squared, I'll get dx if I divide through by this. So let me even do it here carefully. 1 plus 1 over x squared, and here also 1 plus 1 over x squared. So this cancels out this. I'm left with dx equal to, so rewriting that, my dx will now be equal to du over 1 plus 1 over x squared. So I can now replace dx here with this new value. So rewriting this, I have the integral of, let me shift that up big, 1 plus 1 over x squared over u squared, because we've made this one our u already. Remember, it is already u, so I'm writing this one as u, and I put a square also. Then this dx will now be this whole value, since dx is now this value. So I'm putting du over 1 plus 1 over x squared. And of course, finally, this can cancel out. These two can cancel out. I'm left with just what? 1. So I'm left with 1. So this here 1, this here 1. So I'm left with 1 over u squared, then du with respect to the integral of 1 over u squared with respect to u is okay, since this is a change of variable now. So continuing from here, I can now easily integrate. So this will now be, rewriting this gives me u raised to power minus 2 from laws of indices. Then I can now add 1. Remember the direct method, add 1 to the power, bring everything down, minus 2 plus 1, and then you have it as u raised to power minus 1 over minus 1. And if you divide it by minus 1, you get minus u raised to power minus 1. Then what is our u? You can now have minus 1 over u. Yes. And what is my u? Remember, my u is x. From the beginning, my u is x minus 1 over x. Don't forget that. So x minus 1 over x is my u. So that'll be minus 1 over x minus 1 over x. Then I can still simplify further. X minus 1 over x. Let's do that quickly and carefully. So x over 1 minus 1 over x. The LCM here is x. X divided by x is 1. 1 times 1, 1 minus x divided by 1 is x. X times x is x squared. So I have x squared minus 1 over x. So this is now minus 1 over, this now simplifies to this one here, x squared minus 1 over x. And of course, if you divide 1 by this, this will invert. So you now have 1 divided by this now gives me x over x squared minus 1. Of course, the negative sign is there, and I can pull it down, and it will affect the 1 here. So I now have minus times everything down here. So that will be x over minus times minus is plus, then minus times plus is minus, x squared, then plus c, since it is not a definite integral. So that's it.